All right, we are live. So, what's up, everybody? This is Ray, and welcome to our monthly Tech Talk. This is our 13th Tech Talk, and this month, tech editor Ryan Nystrom is giving a talk on Facebook Pop. If you haven't heard of Facebook Pop, it's an open source library for iOS and OS X that makes it super easy to create beautiful animations, such as the spring and decay animations that you see in Facebook Paper. So later on today, hopefully we will be joined by the lead developer of Facebook Pop, Kimon Sinteris, and two of the key members of the Facebook Paper team, Brian Emerich and Grant Paul, who have been using Facebook Pop and Facebook Paper to make some amazing interactions and animations. So here's today's schedule. First, Ryan will give a talk about Facebook Pop and show you guys a cool demo of how you can use it in your apps. Then, hopefully when Kimon, Grant, and Brian arrive, I'll introduce them and give them a chance to say a few words about Facebook Pop and how they used it in Facebook Paper. And finally, we'll open things up to Q&A. So if you're watching this live, you can submit any questions you have with the Q&A tool and upvote other people's questions. Later on in this talk, we'll go through your questions based on those with the most upvotes. So again, first up is Ryan's Tech Talk. Ryan is a tech editor on our site, and he recently attended Facebook's F8 Developer Conference. You might have heard about his experiences there on our podcast, or you might have seen him write about it on a post for our site. He's also the lead developer at a mobile consulting company called Dynamit. I think I pronounced that right. He's a passionate open source contributor, and in his spare time, he also enjoys flying planes as a private pilot. So now I'll turn it over to Ryan for the Facebook Pop Tech Talk.
Cool. Thanks, Ray. Yeah, it's Dynamit. You're close. So I'm going to go ahead and jump into a quick presentation that I have about Facebook Pop. And this is pretty high-level overview about what Pop is, what it does, what it's like to use it, all that sort of stuff. So let's jump right in. What is Pop? Pop is a project by Facebook. It's an open source project up on GitHub that was born out of the creation, at least my understanding, born out of the creation of the app Facebook Paper. If you haven't seen Paper or used Paper before, it's probably one of my favorite apps on my iPhone. I actually deleted the original Facebook app because I like using Paper so much. I've got some animations from Paper in the next couple slides, and you can see why I was so excited to see that Facebook released this open source library to make these animations. This library, API-wise, is very similar to core animation. You'll notice that creating animations, defining their properties and what they do, where they move to and from, is very similar to core animation APIs, even the way you attach it to a view. But it's actually incredibly more powerful. Pop is included with some delightful timing functions. And what I mean by that is typically in UIKit, when you're making an animation, you have a linear timing function. That means it moves from point A to point B in a linear fashion over time. Then you can also get into easing in, easing out. You can get into some ease in, ease out, and then you can even make your own custom timing functions. But what the Paper team has done is create this library with some very, very easy to use animations with incredibly accurate and beautiful timing functions. I think the spring animation is probably one of the coolest things I've seen. And in the demo, I'll actually show you UIKit versus Pop with their spring animations, and you can judge for yourself what you think is better. Probably one of the most important things about Pop is that it works on the model layer. And what I mean by that is that when Pop is changing attributes about a view, it's changing them in real time. It's changing them over that time from A to B while the view is moving. So if you were to ever query the view in the middle of that animation and say, hey, what is this view's x coordinate? You'll get the real x coordinate at that time. With UIKit, that typically runs on the presentation layer, which means that if you're moving from A to B over 1 second, the property is going to be stuck at A until you hit that 1 second when it will be switched to B. And for those that have played with core animation or UIKit animations, you probably noticed that sometimes it can be a little annoying to have to add the B or set it at the beginning of the animation. or to cancel the animation when a user starts interacting with the app. It can be incredibly annoying. One of the other great things about Pop is that you can set animations on custom properties and objects. What I mean by this is you're not bound to a set number of properties that you can animate, like frames, centers, colors. Pop actually lets you define your own functions for how you manipulate values on objects. And you don't have to just add Pop animations to views and layers. You can add your Pop animations to your own NSObject subclass and animate any property on that class. It's pretty awesome. So I'm going to go ahead and show you guys a couple awesome paper animations. This is pulled from a blog post that did some reviews of Paper's animations, and I've got a link to that at the end of this presentation. So first one, hopefully latency is not too bad, but this is when you're choosing the different topics that you want to show up in your feed on Paper. You can see there's a ton happening here. It's too bad I wish I could slow this down like 1,000 times. But you've got the main view pulling up, you've got these cards at the bottom sliding in, and then if you notice, after all the burst animation happens, those cards at top are kind of wiggling. Really, really slick. This next one is looking at a comments list. And you can see awesome animation again, with all of those avatars kind of sliding down. And in UIKit, this would have been really difficult to do. But with Paper, not so hard. And finally, the last one, this is more of an interaction that the only time an animation would really be happening, at least I'm guessing, is at the end of that interaction, the view kind of pops up back into place. But you can see the incredible amount of detail and work that's going into these subtle interactions. So let's take a look at how you used to do a spring animation before iOS 7. This is kind of a mess. This is what some people call callback hell. You can notice that we've got an animate with duration inside of an animate with duration inside of an animate with duration, all with their own times. Usually you would probably reduce each of those times to make it shorter and shorter. But then the idea is that you're animating past where you should be, then you're coming back just a little bit, and then you're putting your view in its final frame. So it gives it a sort of bounce as it comes to rest. Now, something to note here is that if you wanted your animation to look more fluid, you'd either have to add more callbacks so that you could have a bunch of bouncing, or you would have to write your own physics equations and have it dynamically add callbacks and figure out its position and timing so it can do it for you. There have been some libraries that people have made to do this. Some of them are pretty great, but so far, in my opinion, none of them are quite as good as Pop. Then in iOS 7, Apple decided to add animate with duration using spring with damping and initial spring velocity. This was awesome. I was so excited when they came out with this. But then I started using it, and it's perfect as I thought it would be. Your spring with damping is a value from 0 to 1, and your initial spring velocity is, again, a value from 0 to 1. Figuring out what those mean is a little bit difficult, a little non-intuitive, and when you're thinking of increasing the velocity, you would think that your view is going to start off faster, when instead it's actually the opposite. Damping works kind of the way you'd think. The higher the number, the more dampened your animation is. This was incredibly helpful. I really liked when Apple added this, but one of the biggest problems is that you're constrained to the properties that Apple says you're allowed to animate. And that's on UI views and CA layers. So then Pop came along. And I should have written down the release date of Pop, but something like 5 or 6 months ago, I believe now. This is how you create a spring animation in Pop. Now, I'm just going to jump back a slide kind of a lot happening here. And back before iOS 7, it's horrible. There's a ton happening. With Pop, you can see we're creating our animation, and at the end we've got that kpop view frame, which is basically saying we want to animate the frame of a view. We have our to value, which is a value that we want to animate the frame to, wrapped up in an NS value because Objective-C is Objective-C. Then we're defining a spring bounciness and a spring speed. Both of those are values from 0 to 20, 20 being the max. When you're at 20, you're either very bouncy or you're moving super fast. And then you add the animation to your object. Here we're just using view. Notice that the function itself is prefixed with pop, just to help with namespacing, again, because of Objective-C. But if you've ever done any core animation stuff, you notice that this is really similar to what we used to have to do. Creating a CA animation object, adding some properties, adding some configuration stuff, and then adding it to a layer, almost exactly the same way. But what you end up with is a much simpler, cleaner piece of code and an awesome spring animation out of the gate. It's able to infer that when you're adding this animation to your object with that property, you probably want to start with the current value. And again, like I said, Pop is working on the model layer, so as this animation happens, that model layer is continually updated. Some other cool things about Spring is that you can tweak the tension, the friction, and the mass of the spring. So you can get really fine-tuned using real physical properties. It's awesome. Now here's one of the most powerful things about Pop. Remember before I was talking about doing custom animations, animating custom properties. So here I'm actually creating the Pop view frame. That shouldn't be there, but ignore that for now. I'm creating a spring animation, and I'm creating a custom property. This is this Pop animatable property object. Inside of that, I have a read block, a write block, a threshold, and then after that, I'm setting the property of my spring animation and the value I want to go to. Then I'm adding the animation to an NSLayout constraint object. So I'll kind of show you in the demo what this can look like, but basically what's happening is I'm telling Pop, this is how you should animate my NSLayout constraint. When I've given you a from value, when you've inferred a from value, and I've given you a to value, this is how you get from A to B. These are the things that you set. Probably the most important line is in that prop.write block, where I'm setting the constant of the constraint. So if you've ever done work with NSLayout constraints or auto layout, you can set the constant to different values in view.load or in an animation to change the layout of your scene, your view controller. So with this, I'm doing it in Pop, and what's awesome is that it'll also update relationships with that view. So your whole auto layout configuration will move with this Pop animation. The demo is pretty cool. So enough talking about the demo. I'm going to go ahead and pull this up. Desktop. All right. There we go. Sorry, I had to double check. So what I've done is I've created just a simple split view controller list detail app to demo some of the coolest things about Pop. So this very first one, we're going to look at Pop versus UIKit animations. Now, this project's up on GitHub. The video latency might be a little rough, so you're not going to see as good of detail as I'm going to see. But I encourage you to download the project when this is over, play around with it, and tweak and see for yourself. So if I click on this UIKit, I can see I get a nice little spring animation. Pretty simple, pretty basic. When I click on the pop, I get the same thing. But you notice it's a little bit more fluid. It seems a little bit more natural. And I think that this is most likely due to the fact that with the UIKit animation, I have to define a duration. So I have to tell it from point A to point B, I need you to animate within half of a second, which I believe is what this is set to. With pop, all I'm telling it is you need to go to this value, and your spring is this bouncy and is moving this fast initially. And it just looks awesome. Now pop's got, aside from custom animations where you're defining your own functions, pop's got 3 types of animations. You've got your spring, which is what we were just looking at. You've got your basic, which is just as it sounds, a very simple animation. Notice it eases a little bit there at the end. And then you have a decay, which eases a ton. Decay is kind of interesting. If I jump into our code here, the decay, I'm not actually giving it a to value. I'm giving it a velocity. So I'm telling it.
Hey Ryan, sorry to interrupt. Can you turn on presentation mode in Xcode? Go to Xcode preferences so we can see the code a little bit easier.
Oh, that'd probably be helpful. There we go. Better?
Yep, looks good.
Cool. So here I'm creating a pop decay animation, changing the position Y of my layer, and I'm giving it a velocity. So it's just going to have this much velocity applied to the object and move however much I test. This is just a toggle between going up and down. So I'm just telling it to move 900 or go up 900. And that's it. Create an object, set a velocity, and then I'm adding it to my view. Really, really simple. Now, if any of you have ever seen some of my work before, you could tell that I'm a huge, huge Reactive Cocoa fanboy. I think it's awesome. I love what it brings to Objective-C. We'll see if Swift, if they're going to port something over to Swift, or if Swift will be able to stand up on its own. But what I've done here, and I'll jump into the code before I run anything. Is I've set an observer. I'll separate this out a little bit. Set an observer on the frame property of this view. And every time that frame property gets updated, I want to go ahead and print it to a UI text view that I've added to our scene. Now you could also do this with key value observing, but I'm a Reactive Cocoa fanboy. But ideally what will happen here is that every time that frame property changes, we'll get a new print to the log. Now if I were to do this with UIKit, it's not going to change until the animation is done. But with Reactive Cocoa, if I tap on this, you can see all of the XY coordinates on the right updating as the view is animating. So if I were in the middle of an animation and I wanted to cancel it, or I wanted to query the view and say, where are you right now, I would get an accurate representation of what's happening on the screen. Finally, let's look at some interaction stuff. Sorry, not finally. We've got an avatar in the middle of our scene, and we've got a pan gesture attached to it, so I can move this around and do whatever I want with it. Now what's cool here is that when I let go, I have a spring animation that's going to send this view back to the center of the screen. Nice and simple animation. Very little work to get that to run. What you'll notice is that depending on the distance from the center, the animation is smaller or larger. So if I just pull it a little bit away and I let go, just a tiny little wiggle. But if I pull the avatar all the way up and let go, it's a huge bounce. And if I show you the code for this, come on, Xcode. This is all that the animation code is doing. I'm just creating the spring animation like I showed you in the presentation and adding it to the view. I'm not determining how far away it is from the center. I'm not doing any math. I don't have to do anything. I just create the animation, slap it onto the view, and I walk away. Really, really simple. Now let's look at some custom property animations. I'm using BC Mesh Transform View, which is again in the notes at the end of the presentation, which is a really cool library to do 3D mesh transformations on views. There's some awesome blog posts out there that I can also add into the presentation notes. But it's a non-trivial view to set up. It's not supported by Pop out of the box. I have to go and I have to manually set up everything, how Pop should determine how to get from A to B. But when I do that, I get an awesome animation, opening the curtain, closing the curtain, getting a nice shot of Rick Astley in the background. And you can see the subtle bounce that's happening because of Pop's spring animation. And finally, let's look at auto layout. So remember before I was talking about how you set up, you set up your read and write blocks for auto layout. This code that we're looking at here is exactly what was in the presentation. When we're reading the value from the constraint, we're just getting the constant, and we're passing it into this values CG float array. And then when we need to write the value to the actual constraint, we're getting, notice we're setting it at value 0 here. We're getting that value from here and setting it to our constraint. So as this constraint is being animated from A to B over whatever time, this line right here is going to be writing that constraint and updating the scene. Now if we look at the actual storyboard where this is happening, I can open up all of our constraints here. There's a ton of constraints that we have set up on our avatar, our Facebook logo, our label. But if you notice, height constraint right here is the only thing we're going to animate. We're going to put a spring animation onto this, and what we want to happen is everything else in this scene update as this height animates. So let's take a look at that. Now what's going to happen is I'm just setting a random height to this and using a Pop spring animation, so hopefully this is bouncy. And there we go. You can see that all of the constraints are maintained. This is staying up in its top left, bottom left. The label's stretching. And when things are changing to their new heights and their new positions, they all bounce. It's not just the container's height. All of the constraints on the inside are updated as Pop is animating. And this happens just completely out of the box. So I've got links that we'll have up online after we post the presentation up. That is actually all I've got. The demo project itself is hosted up on GitHub. Again, we'll have that link once everything goes up on raywenderlich.com. I appreciate you guys coming and listening to me.
Awesome. Thank you so much, Ryan. That was great. And like Ryan said, we'll put the links for Ryan's slides and source code up on the site after this talk is over. And thanks for the presentation, Ryan. It was really great and really demonstrates how cool and easy to use Pop really is. So I want to get into questions from everybody who's watching. And remember, just keep the questions coming, keep the upvotes coming. But before we do that, I wanted to introduce our special guest from Facebook and give them a chance to say a few words. We have 3 of them with us, and we'll start with Kimon Santeris, who's the lead developer of Facebook Pop. Kimon worked at Apple on the original iPhone and iPad, and he later left to co-found PushPop Press, which is an electronic interactive book publishing platform, which was then acquired by Facebook. And at Facebook, he was the engineer lead on the web-to-native transition, and now he works on Paper and Pop. So, Kimon, I was wondering if you could tell us a little bit about why you originally made Facebook Pop and how it has developed and grown over the years. You might be muted right now, so click the the mute button on the top.
Got it. Hey, Ray, can you hear me now?
Yep.
Cool. Thanks for having us. Ryan, that was a great walkthrough of POP. It's been really fun to kind of see what people have been building. As far as POP, it actually goes back quite a ways. It's actually a technology that we built at PushPop Press. We were looking at building our own kind of scroll views, our own kind of unfoldable attachments. We quickly realized we actually wanted the whole interface to be as lovingly crafted as UI Scroll View was out of Apple. UI Scroll View was kind of this magical, mystical beast. It's the one that rubber banded and bounced and kind of had that delightful, playful nature. We wanted the whole book, the whole interactive book experience to be, and there really was no framework, no encapsulation that we could actually use to leverage, you know, that springiness and that playfulness throughout the whole app. So that was actually the genesis of it. When we brought it over, when we came over to Facebook, we realized there were a lot of things that we could kind of improve upon. Originally, just animated layers. That's kind of how our programming environment was set up. But we realized other people wanted to animate views. We had our own around asynchronous display here at Facebook, something called a display node. We wanted people to animate that. We quickly realized that there was no real reason to kind of couple animation with the type of object being animated, let alone the property being. We slowly added on basically arbitrary vector support, the ability to animate arbitrary objects and arbitrary properties, and yeah, it's been really fun to kind of watch what the community, once we open sourced it, has decided to build with that.
Yeah, we were all very excited to see that open sourced, and I've been enjoying playing around with it. So thank you. Next up, I'd like to introduce Brian Emerich, and Brian is the engineering tech lead for Facebook for Paper at Facebook, responsible for the app's gestural architecture, openable interactive attachment system, which uses POP heavily, photos infrastructure, likes and comments UI, WYSIWYG story composer. And prior to Facebook, Brian was the founder of a small software outfit that shipped 2 apps, Flow and Seamless, to over 100K happy users. So, Brian, could you tell us a little bit about how you use Facebook Pop and Facebook Paper?
Yeah. Thanks for doing this, Ray, by the way. This has been great. So as you know, Paper is almost entirely gesturally driven, and we use animations in Paper as sort of a physical continuation of a gesture within the app. So after nearly anything you do in the app, whether it's any gesture, whether you're scaling up the story strip, or you're pinching open a photo, or you're unfolding a link attachment, what follows when you lift your finger is an animation, and that's a pop animation within Paper. And everything we build, everything in Paper is built to be completely interruptible, and pop makes that really easy, really straightforward. So we use it for pretty much every animation in the app. It's almost constantly pop, animating with pop.
Yeah, the animations in Paper are incredible. We actually had a best iOS 7 animations post a little while ago on our blog, and Paper won hands down. So great job on that. Okay, there's one more developer from Facebook I'd love to introduce, and it's Grant Paul. And Grant is a programmer at Facebook, and he's worked on the mobile infrastructure and chat heads, and now he works on Paper. He maintains Facebook's open source project Shimmer and Tweaks, which I also recommend you all check out, and he contributes to POP. So Grant, my question for you is, Facebook has really been contributing a lot to the open source community lately with Shimmer, Tweaks, POP, Origami, and more. So I was wondering if you could tell us a little bit about Facebook's experience with open source, why you're doing this, any benefits you're seeing, and what the community's reaction has been to all these open source projects so far.
Yeah, it's been really fun to work on this open source stuff. So when we were working on Paper, we came up with all of these different technologies and just techniques and stuff for building parts of Paper. And once we launched Paper, we sort of looked at it and we saw a bunch of them that would be really useful outside of Facebook, and we were even starting to use them in other apps at Facebook, and we thought other people would want to use them as well. And so we thought, well, if we have this code and there's nothing that's too tied to Paper as a specific app, we should just open source it, and then anybody can use it. And that went really well. We saw a lot of people seem pretty interested in them. We got a bunch of patches from people outside of Facebook, and we had a bunch of bugs fixed and a bunch of new features added. So it's been really awesome to do that. And it's also really another purpose of it is that we sort of want to drive progress forward and the sense of design and animations that we see in apps. So you have something like Origami, which, if you haven't seen it, is a plugin to Quartz Composer to let you do interactive UI design in Quartz Composer. That works really well in Pop, and so you can use the same values from Origami in Pop, so that when the designer comes up with a new design for something, they can use that in Pop, and they can build up the same kind of interactive and fluid interfaces that similar to what Paper has. And we think it would be awesome if more apps had stuff like that.
Great, thank you. Okay, so we're going to get on to the Q&A now, and we're going to start with the current top ranked question, which is from Ander Paterson. And I'm going to kind of rephrase this question a little slightly. But the question number one is Pop using core animation under the hood, or if not, how does that work? And second, what is the difference between using Pop and just using regular animation methods? And so whenever I have questions like this, anyone feel free to jump in.
Okay, I think I can take that one. So core animation, just about most iPhone, iPad apps are using core animation, and Pop is no exception. Core animation does two things. It does both the rendering, compositing, and also the animation. So in that sense, it's a framework that has two purposes, and it's very tightly coupled. And that was basically a design decision with the original iPhone in order to support really fast animations, smooth animations on very constrained hardware. Fast forward, many years, Pop actually decouples animation from rendering, and that actually has a number of advantages. All that presentation layer stuff, if you actually try to build an interactive, interruptible UI using just straight up core animation, you'll quickly realize that the objects you're animating are actually not the ones you see. There's a whole nother layer tree called the presentation layer that if you actually want to build interruptive animations, you actually need to deal with this whole separate tree. So there's a big overhead when you actually go down that route, just in terms of cognitive overhead, and as well as performance. Animating just the model layer oftentimes is kind of just like a simpler, conceptual understanding of what is actually transpiring. So in that sense, Pop uses core animation for rendering, but takes the animation part of core animation and splits that off into a separate library, which, as you've kind of seen, you can animate all sorts of things, like arbitrary properties on, NS layout constraint, etc. So yeah, we're definitely still using core animation under the hood, because most likely your app is using core animation under the hood to render all its views and layers. Oh, sorry, we lost you for a sec, Ray.
Yeah, can you guys see me okay now?
Yeah, absolutely.
All right, the next question is actually from one of our tutorial team members, Marin Todorov, who's here with us. So Marin, you want to take this one?
Yeah, sure. Guys, an amazing library, definitely awesome work. And I actually have like 20 questions, but I'll just pose one now and then we see if there's more time. I wanted to ask you why there weren't any examples and any demos included in the GitHub repository, because like we're kind of like in this kind of business around rarewinlink.com, and I was really looking for cool demos, like the best demos would come from the authors, right?
Sure, absolutely. I mean, at the end of the day, building Paper and building some of the apps within Facebook are our primary focus areas, and that really kind of open sourcing is definitely something that we have to allocate time for and argue, with our managers and kind of our, internally our project managers to make time for. So, at the end of the day, we really wanted to kind of just get something out there. And at the same time, we don't want to, for lots of reasons, we don't actually want to show too many UI examples. Our hands are somewhat limited because this is a somewhat sensitive subject in terms of the types of UIs you can build. This is kind of getting into more like legal patent areas. We basically kind of felt that the best thing was to put it out there and let the community kind of see what they would come out with. And honestly, the community has been probably maybe even more creative in its application of POP than we could have been. So really, there was a hole, but the community kind of filled it in very, very quickly, and let us get Paper 2 and all the other things that we have going on in here. So.
Yeah, and it's all kinds of things about like if you look at for example, on the Pop GitHub page, we have a whole list of examples now that are all contributed by the community, and a lot of those are doing things that like we had never even thought of. Like there's some that add proxies for different properties to make it much easier to set up animations, and those kind of things are really cool. And it's the kind of thing that like we have never even thought of. And so by putting it out into the community and just seeing what people come up with, we've seen all of these different things that we really couldn't have thought of before.
Thank you. Thank you. Ray?
Yeah, and actually, this leads sort of into a question that I know Ryan had about working with designers. Ryan, you want to ask him that one?
Yeah, I was just kind of interested what the workflow was like for you guys when, you know, how do you go from an idea to conceptualizing an animation or an interaction to actually building one and then fine-tuning it? Can you guys speak about that process at all?
So, I mean, we generally start with Quartz Composer with Origami, which we've done work to open source a lot of that. So we start prototyping in Quartz Composer, which I think, is that using Pop under the hood now?
Yeah, now.
So that's using Pop under the hood, actually. So it's the same animation engine in both directions, and when we actually get to the point where we want to get this on a device and start playing with or building a real version of it, we can use the same animation values, same physics constants that we use in Origami in Pop, in the actual app that we build. So we basically start with Quartz Composer. We feel it out there, see how it works, tweak, iterate, and then we start building the actual version with Pop.
I would just add, we have a very tight, closed kind of feedback loop with design. Design kind of sits next to engineering, and the distinction is very much blurred. Designers, if you talk to them, are actually thinking of very similar engineering problems, encapsulation, how to package something up and make a reusable component. And in having seen Quartz Composer and Origami in particular, that's actually inspired a lot of some of the projects that we've open sourced. The ability to quickly change values without rebuilding, recompiling, that's tweaks. So there's been a lot of synergy back and forth. Designers come to a problem with a different mindset oftentimes, and so kind of just understanding them and working with them has definitely, I think, helped both disciplines.
Great. Here's a question that's actually asked by two different people, Homer's Ghost and Doran Katz. And the question is, if or when can we expect to see a Swift version of Pop?
Well, Swift isn't, officially out yet. It's still in beta. Apple kind of indicated that they might still be tweaking the language itself. It's not going to be source compatible. Basically, we're an open source project, so we depend on Travis CI for continuous integration. We really need our whole tool chain on GitHub and Travis to really upgrade and support Swift before we can actually, adopt it. That said, we're definitely playing with Swift internally. Keep an eye out for a Swift version as soon as it's actually mature enough and ready to use.
And I will point out that I also recently saw on GitHub somebody put up a wrapper for Pop that's compatible with Swift. We still probably need to iterate and look at what the best syntax is, especially as everybody gets more comfortable with Swift. But it looks like if you want to start playing with Pop and Swift, there's already a way you can start doing that now.
Okay. Anybody here, Ryan, Maren, have any more questions? Yeah, Maren?
Sorry, I actually have a super quick one. I was thinking in the direction what kind of applications there could be to Pop outside of things that you actually see on screen. Did you guys do any animations to data or just model properties that are not really related to anything on screen, anything visual?
Sorry, I had to mute you guys a second ago. Okay.
Yeah, so we use Pop for a bunch of different things. So one of the most common things with Pop, it's sort of still driving something on the screen, but you would sort of animate a logical value that's sort of like a progress from 0 to 1, and then we'd use that progress to then drive the progress of many other animations. So if you see things in paper that are sort of synchronized together, or all seem to be like attached to the same spring, we might have a single progress animation going in the background, and then using that value to update all different things. more to your point though about like animating things that aren't visible on screen, one of the more fun things that we tried doing was using Pop to animate the volume of a video player. So when you like tap on a video and we want to sort of fade in the volume for it, you could use a spring animation on the volume or a decay animation to sort of naturally bring up the volume to another level in a way that there's no sort of like animate volume method built into iOS. You can just do that straight with Pop, and it works great. I don't think there's been any cases where we've needed to animate model values, usually because, especially with something like like paper, a lot of the values sort of come down from the network and then are just used on the device directly, and so we don't really have any reason to sort of animate them between different things. But if you did have some case where that made a lot of sense, then you could definitely use Pop for it.
I think another interesting example is in the unfoldable link attachments in Paper. When you're interacting with that, that's actually on a spring the entire time. And when you put your fingers down initially, it's on a looser spring, and then we tighten the spring as it actually folds up. And so you get this kind of neat bounce effect where when it comes up to your fingers, it bounces, but then when it's under your fingers, it's smoothed by the spring, but it's a very direct interaction because we've made the spring really tight. So that was a fun one.
Yeah, and similar to that, we've had other examples where we sort of use the Pop animations in a sense as a filter. So if you're getting in values from different areas, like let's say the accelerometer or the gyroscope, or other different types of sensors on the phone, sometimes those can come in as sort of discrete values, and if you just put them straight on the screen, things can sort of jump around a little bit. And so what you can do is you can use Pop to sort of smooth out by passing all the values through a springs. Because the springs support smoothly changing to a new target value, if you change the spring to just go to whatever target the sensor brings in, it'll sort of smooth out any any different like discrete values that are coming in from the sensors. And so when you put it on the screen, it looks very natural and smooth.
And an earlier version of that, the early version of tilt to view photos in Paper, where you can sort of tilt around and see around the photo, the early versions of that actually used a spring to smooth the sensor down.
Yeah, think of oftentimes it's very useful to kind of look to the analog world, and basically what both Grant and Brian are describing is basically kind of like imagine a car driving down a bumpy road. Like we actually use springs to absorb that shock, right, and kind of smooth out the ride. Yeah, springs are actually used in lots of different places, and with interesting applications beyond just the bounce, visual position change that you might just instantly associate with.
Thank you, guys. Even only listening to you speaking about how Pop can be used is really inspiring. Thank you a lot.
Okay, thanks, guys. The next question is from Alexis Gallagher, who's a tech editor on our site, and he's wondering, what does Pop do that UIKit Dynamics already does, and vice versa, what does Pop do that UIKit Dynamics does not do?
Okay, I'll take that. So UI Dynamics is a very interesting framework, and we're often kind of inspiring Apple, and they're inspiring us, in kind of a game of cat and mouse or leapfrogging. UI Dynamics is actually a very full-featured framework out of Apple that's very good for building cohesive worlds like game design. It's very similar to Box2D, where basically you have to model all your different objects and give them behaviors, properties, and then let that world go off and simulate. That works, except that it's a very big paradigm shift from your normal animation code, especially if you're writing core animation and explicit animations and trying to build some really fine-grained interactions and UI. That's basically the world that we're coming from, and throwing all that out and going with UI Dynamics is actually a really big shift in terms of programming paradigm. We really focused on making Pop as close to a one-to-one replacement, leveraging some of the many really nice aspects of CA and the API that CA provides with explicit animations, but kind of opening it up to arbitrary objects. So it's definitely not one or the other. We just find that Pop basically fits our programming model a little bit, allows us to kind of, if there's an animation that we don't actually, if there's an animation that is not actually provided out of the box, we can always just tap in and write our own custom animation, basically just one level above, CA display link. So it basically kind of is made so that you never get to a point with the programming model where you basically have to say, oh, I have to start over and adopt some whole new programming paradigm.
Okay, thank you. One more question from Andrew Patterson, and it's going back to what Ryan was talking about with the new Spring animations, and I think if I recall, they were actually released in a beta, like iOS 7.2 or something like that, not iOS 8. But the question is, under what circumstances would Pop be a better choice than using that API?
Basically, yeah, to follow up on that, Apple is just recently adding, Spring animations, iOS 8, UI Dynamics, iOS 7. Pop also supports iOS 6, and with a little bit of work, we could probably backport it even further. Pop itself is not necessarily tied to one specific iOS version or platform for the matter. We also have it on OS 10. So in that sense, I think it affords people more flexibility. And like I said, I think it's more a model, a programming paradigm model. UIKit is very good with set it and forget it animations, but try to query an active UIKit animation. It really is not very easy, and that is something that CA actually does have, but many people often don't make the jump. And when it comes to CA, there is no Spring animation in CA that's actually exposed in UIKit. So UIKit and CA, it's been kind of especially UIKit has been kind of an evolutionary design. They're trying to add in and retrofit some of their APIs to support more interactive user interfaces. But we just think that Pop is kind of a less opinionated, more flexible framework in that sense. Being able to query the current state of an object is very simple. You don't actually have to keep track of whether an animation is progressing. You can actually just query the animation, much like CA allows you to query your object for the animation key that you added. So in that sense, you don't have to have additional state tracking whether or not you're in an animation.
Yeah, and just to add on that, the sort of long story short of what that means when you want to build interactive interfaces. If you want to build animations that are interruptible, whether they're from a discrete gesture like a tap or a continuous gesture like a pan, Pop makes interruptible animations really easy because you can both update the to value of where the animation is going, and because you could remove them and re-add them. Because they're applied to the model layer, removing them is pretty much inconsequential. Everything is exactly where it was as it was animating, which is a different behavior than you'd see from a CA animation, and unlike the UIKit's Spring animations, you can actually cancel them very easily.
Ray, you muted again. Sorry.
Sorry about that. I think we have time for one more, and then we're going to go on to final sentences from everybody. So this one's from Brandon Roeder, and it's how many developers are currently working exclusively on Pop?
There are fewer than you think. I mean, if you count the open source community, there's actually a number of people that have contributed. I think we're well past 20 contributors. But it really is a spare time project for us. This is some of the technology that we've built in order to support Paper. But yeah, it really is just a part-time passion for us. So. And for a number of people, actually. Some of the contributions have been really, really impressive from all over the world. So we definitely welcome your help and your contribution in continuing the framework. There's a lot of things that we want to add, and we're just trying to make time. So.
Yeah, and so basically it's as we work on Paper, we see different things that we need for Paper, and we build those into Pop as they're there. But if there's something that, for example, Paper would never need, but that would be really useful in Pop for maybe some other kind of app or something like that, that's the kind of thing that is really great for people who are using Pop in other contexts if they want to contribute back. For example, to get all the features in there are useful for every kind of app.
Okay, great, thank you. So at this point, I was just wondering if Grant or Brian or Kimon, had any final things you wanted to mention to our listeners about Facebook Pop, any open source projects you're working on, just anything that you think would be good for us to know?
I mean, very open-ended, but you know, I think this this experience has been very positive for us. You know, we've actually really enjoyed kind of packaging up little morsels of our labor over the last couple of years and putting it out to the community. And we're really kind of open source has definitely been in the DNA of Facebook, and I think Facebook has used open source in many other parts of the stack. It's really exciting, and we're really kind of honored to actually be able to contribute back to the iOS community. I think all of us, you know, have been longtime members of the iOS community and Mac community, you know, Coco. So we're kind of really excited to be in a position where, you know, Facebook is actually kind of at the point where we're actually contributing back and able to share some of our work with the community that we've kind of been involved with for so long.
I think just on top of that, I'd like to just do a final plug actually for people to try Pop. Kimon spent an enormous amount of time making the API for Pop really compatible and natural if you compare it to something like Core Animation. So it's actually a lot less work to move over to Pop than some of you may actually be thinking. And it's a very natural model to work with within iOS apps. So I think it's just a final plug to go give it a try, because you could build some really awesome stuff.
Yeah, and I guess what I would say is, so if you're interested in Pop, and then also we have a bunch of other open source things that are both released, and then we have another one called Async Display Kit that's coming out soon. We have a group on Facebook called Paper Engineering Community. And if you join that, we have some discussions about how to best use Pop and how to, and also you can get beta access to the new projects as we're sort of polishing up the APIs to open source them. So I just suggest if anybody's interested in those, so check out that group and check out the new things that we're trying to open source, and let us know what you think about them.
Yeah, this won't be the last project that we open source. We're kind of committed to the process, and we've definitely enjoyed it and benefited from it. So, you know, stay tuned for more.
That's awesome news to hear. So to follow up with what the Facebook guys just said, if you want to learn more about Pop, we'll be putting this video up on the site with Ryan's demo, so you can look through that as an example. And Ryan, you're also working on a tutorial about Facebook Pop, a written tutorial, right?
Yep, and that'll be incorporating Pop, kind of doing some more advanced animations and transitions, and also experimenting with a little Swift too. Sweet.
So definitely stay tuned for that as well. So we're going to wrap it up for here, but before we go, I just wanted to say a huge thanks to Ryan for putting together this tech talk, and to Kimon, Brian, and Grant for joining us, and for developing and sharing Facebook Pop with the iOS community. So thank you.
Thank you.
Thank you, guys.
This has been really fun. Thank you, Ryan.
Yeah,
thank you, Ray.
for running this event.
Thanks for inviting us.
Okay, so last but not least, for everybody watching, we have these tech talks every month, so we'll be announcing the next one soon. Just keep an eye on the sidebar of the site, and thank you so much for watching. I hope you enjoyed it, and we'll see you next time. Bye, everybody.